Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, we will discuss the basics of signal flow graph. First, what do you mean by signal flow graph? It is a graphical representation of the control system and its flow of signals. And also, it is a network graph in which variables are represented by the nodes. Variables are such that input variable and output variables. So, input variables is nothing but reference input. Okay. And then controlled output is the output variable. So in between intermediate variables are manipulated variables. So that variables can be represented by a separate nodes in the signal flow graph. Then conversion of block diagram to signal flow graph. So for the conversion of block diagram to signal flow graph, there are various points to be considered. So I will tell you the important points. First, R of S and C of S. That is, R of S is nothing but Laplace transform of reference input. C of S is the Laplace transform of controlled output. So, input and output that should be represented by separate nodes. Input and output nodes in the signal flow graph. And the next point, summing points. So, block diagram may consist of several summing points and several takeoff points. So that summing points can be represented by nodes. And then takeoff points. So that also should be represented by nodes. And important points are if takeoff point and summing point are nearby each other. So without any block in between means or nearby each other means we can combine that takeoff point and summing point and it can be represented by a single node. We can combine both takeoff point and summing point and we can represent that as a single node. And another point, two or more summing points. So a block diagram may consist of two summing point or three summing point or several summing points are there. That several summing points are nearby each other means we can combine all the summing points then and that can be represented by a single node. And next point, two or more takeoff points are nearby each other. If in between no block is there, means we can combine and we can represent that as a single node. So these are the important points has to be considered to draw the signal flow graph. So to convert the block diagram to signal flow graph. Okay. So here I have given the part of a block diagram. Here I have given one part of a block diagram which consists of system gain G2 and feedback gain H1 and one summing point is there and one takeoff point is there. Here summing point and takeoff point are nearby each other. In between no block is there. So we can combine. We can combine this summing point and takeoff point and we can draw the signal flow graph like this. Okay, this is a single node represented for the combination of summing point and takeoff point. So this this line is for the feedback element H1. Okay, and this line is taken for the summing point output. Okay, so this is the signal flow graph representation for this part of block diagram. And next also I have given one part of block diagram which consists of two takeoff points nearby each other. So here this is first takeoff point and this is second takeoff point. This is nearby each other. In between no block is there. So we can combine this two takeoff points and we can represent that as a single node like this. Single node like this. From the single node, this is first takeoff point output and this is second takeoff point output. So like this, we have to convert the block diagram to signal flow graph. Then one block diagram I have given here. This block diagram consists of various summing points, several summing points and takeoff points. And G1, G2, G3 and G4 are system gains. H1 and unity feedback is there. And then three summing points. This is first summing point, second summing point, third summing point is there. And takeoff points. And here is one summing, here is one takeoff point, and here is one takeoff point, and here is another takeoff point. So three summing points, three takeoff points are there. Two feedback connections are there. So this is first feedback connection and this is second feedback connection. And from here to here, this is a parallel block connection. Now, we can convert this. We will convert this block diagram to signal flow graph. Okay. Now, R of S, input should be represented by a single node. And next, two summing points are nearby each other. In between, no block is there. So we can combine this and we can represent that as a single node. And then next takeoff point that should be represented by a single node. And next one here, third summing point and this takeoff point are nearby each other. So we can combine and that should be represented by a single node. And this takeoff point that should be represented by a single node. And output that also can be represented by a single node. Now, we can number the nodes. Number 1, 2, 3, 4, 5, 6. Totally 6 nodes are there. Now, we will start to draw the signal flow graph. 1, 2, 3, 4, 5, 6 nodes. Okay, number the nodes. 1, 2, 3, 4, 5, 6. Okay. Now, we'll start. From first node to second node, there is no block in between. So, we can take that gain as 1. Okay. We can take from the input node to second node, we can represent that gain as 1. And then from second node is the combination of two summing points. From second to third, one block is there, G1 block, system gain G1. Okay. So, we can represent that G1 gain from second node to third node. Okay. And then third node to fourth node, we are having two connections. One for system gain G2 and another for system gain G4. Okay. So, third to fourth, G2 gain and then G4 gain. That is a parallel block connection from third node to fourth node. So, we can represent that parallel block connection like this. G4 can be represented like this. Okay. Parallel block connection can be represented by a curved line. And from fourth to fifth, see the fourth node, from the fourth node, takeoff point is also there. So that branch point is taken out from the fourth node to the second node. It is connected to the second node. Okay. So fourth to second node for the feedback element H1. So fourth to second node connection, and we can represent that feedback element as minus H1 because it is a negative feedback. Since it is a negative feedback, we should represent that gain as minus H1. That feedback gain as minus H1. Okay. So, see whether some other connection is there? No. Fourth to fifth, G3 gain is there. So, fourth to fifth, G3 gain can be represented like this. And from fifth node, another feedback connection is there. From fifth node, another feedback connection is there to the second node. Okay, to the second node. This is also negative feedback, but unity feedback. So, we can represent that negative unity feedback from fifth to second node like this, minus 1. Okay, minus 1 is represented for negative unity feedback. And from fifth to sixth, there is no block. So, we can represent it as unity gain. Okay. So, like this, we can convert any block diagram to signal flow graph easily. Okay. So, this is the equivalent signal flow graph for the given block diagram. The next one, conversion of signal flow graph from linear equations. So, sometimes system can be represented by its linear equations. So, here I have given some set of linear equations. I am going to convert this linear equations to signal flow graph. Okay, graphical representation of the equations. First, I have taken the first equation. X2 equal to A1 X1 plus B3 X3. B3 X3. Okay. So, X2 equal to A1 X1 plus B3 X3. First, we will find the number of variables. So, X1, X2, X3 up to X4 is there. So, we can represent it as 4 nodes. 1, 2, 3, 4. X1, first node. X2, second node. X3, third node. X4, fourth node. Now we will draw the graph for first equation. X2 equal to. So X2 should be the output. All others should be the input. Okay. All other nodes should be the input. So A1 X1 plus B3 X3. So A1 is the gain coming from the node X1. So that is the meaning. So from X1 node, A1 is the gain. Okay. And then another input is coming from the node X3. So from X3, reverse from X3 to X2. So we can represent by a curved line. Okay. So from X3 to X2, B3 is the gain. B3 is the gain incoming to the output X2. Okay. So now X2 equal to A1 X1 plus B3 X3. So this is the equivalent signal flow graph for the first equation. And then second equation. Take the second equation. X3 equal to A2 X2 plus B2 X2. So totally 4 nodes. X1, X2, X3, X4. Now the output variable is X3. So therefore the X3 all should be the income. From other inputs, we have to take the gains. So from X2, first see the first term A2 X2. So A2 is the gain. It should come from X2. So A2 is the gain. We can represent the line like this. And then B2 X2. So from X2 node, another gain has to be connected from X2 node. So it can be represented by a curved line B2. Now X3 equal to A2 X2 plus B2 X2. And then third equation, X4 equal to B1 X1 plus A3 X3 plus B4 X2. So totally 4 nodes. Now X4 should be the output. Okay. All others are input nodes. X4 should be the output node. And then from X1 node, B1 is the gain. From X1 node, B1 gain should be connected. So already from X1 to X2, straight line connection is there. So for B1 gain, we can represent that as a curved line. We can represent that as a curved line for gain B1. And then A3, X3 from X3 node. A3, X3. We can represent that as a straight line because no other straight line connection is there from X3 to X4. So we can represent that as a straight line, which is having gain A3. And then B4, X2. So from X2, already straight line connection, the straight line connection is taken out, and then from curve also taken out. Another curve from X2 to X4, representing for gain B4. B4. Okay, X2 to X4, B4, and X1 to X4, B1. So this is the signal flow graph representation for the third equation. Now we can combine the graph and we can draw. Completely we can draw. That is the equivalent signal flow graph for the set of equations represented for the system, total control system. Okay, we can combine and we can draw the signal flow graph like this. All are there. All gains are there. Okay, all gains are there. See, all gains are there. So this is the equivalent signal flow graph for the given set of equations. So thus we can convert linear equations to signal flow graph and also block diagram to signal flow graph. Okay. This is Mani's Gate Tech Vision. This is the channel for engineering lectures. Thank you very much for watching the video. Thank you.